Hi, class. I want to talk about the week two discussion and just in general, I want to let you know that the discussions have all been revised, and that's why there's a little bit of confusion if you go to the assignment page first without reading through the announcements and then following those directions. So be certain that you go to the announcements. uh, Remember that the revised discussions are in doc sharing. So I just want to pull up the site. So your site will look something like this. It may not be this number. That doesn't mean anything. It's just that when you go to your Blackboard homepage, then it's going to look something like this. And on the left, uh, again, there's it says doc sharing. So if you click on doc sharing, there'll be files. Now, don't post anything in doc sharing. That's just for me to post for you guys to read. But for example, for week one, you'll see there was the week one revised discussion directions. And there's not major changes, but there's necessary changes to all the discussions. And there'll be a video to help guide you through that. So make sure that you also, um, that the project is there, and then there's like a rubric each week. So there's not a lot in doc sharing, but the most important thing, again, the project and the revised discussion is there. And as you go through your homework, you really should do the MyStatLab homework first, then your projects, which really the projects are there to help you learn how to use StatDisk, the statistical software package that we use for the course. And that's needed to be able to do the discussions. So that's why you really should do the projects first, learn how to do that. But you need to do the MyStatLab homework so you understand the terminology and what's going on. And again, I realize that we're in a revision process, so the beginning is a little confusing, but you'll catch on right away, and it'll become much, much smoother as you go through this. Uh, and so we need the revised discussion directions for week two. And so I'm going to put this down and bring those up. Again, they'll be in doc sharing. And again, there's not a dramatic difference, but there is a definite differences. And hopefully these are a little bit easier to follow. But for the week two discussion, okay, we are talking about descriptive statistics. When you get involved in statistics, it's about collecting data, organizing data, um, trying to interpret the data, and the organizing part of it is very, very important. And statistics is broken down into really two different areas. One is called descriptive statistics, and the other is inferential statistics, which is later on in the course. And you always start with the descriptive statistics. And so that's just trying to find out what you got. So when you go out and you collect data and you want to organize it so you can figure out what's there, initially. And that's what we're doing here. We're trying to look at some of the common descriptive elements that pretty much everybody uses when they get going on a study. And so you're going to go out and think of a scenario that relates to your program. It can be related to job, which relates to your program, can be directly related or indirectly related to the type of work that you do and the program that you're in, and so on. And again, so we just don't want you going out off on the tangents and coming up with some crazy ideas of things and not really relating to your program in any way. So and collect about 20 data values. Now, one thing to remember is I know that some students feel like they get some variables and they're going to use those same variables throughout the entire course, and that's not true. Okay, so there's no variables that work in every single different type of statistical analysis. I mean, that's one of the things that you want to learn throughout the course is that different variables require different types of analyses. So everything isn't a correlation. I get some students that talk about, oh, we're studying the correlation now between these. No, correlation is one type of statistical procedure and only one out of very many different types of procedures. And it is appropriate in certain situations. But so we're going to learn, about a half a dozen different types of procedures, and that's about it in an elementary stat course like this. So remember, we want to always collect data first. And we got to think about the types of variables that we're going to use. Every variable is going to be classified as either qualitative or quantitative, no matter what you're involved in statistics. You have to be able to understand what is a quantitative variable, what is a qualitative variable. And that's why we're doing discussions like this, so that you get a better idea of what those are. That's extremely important beginning of the whole statistical process. So for example here, and for your discussion, you're going to find one qualitative variable. So I have gender here. And again, once these are used in the example, then students cannot use these variables, all right, in theirs. Again, it's kind of like plagiarizing in a sense. If you read something in a book and then you use exactly what's in the book in terms of statistics, what we're doing, you have to develop your own ideas. Now, gender, again, is qualitative, and we see non-numeric. Quality is differences in quality, if you want to call it, but could there be numbers in here representing the different genders? Like males, they put in ones, and females, they put in zeros. Yes, you could do that, and sometimes people do that because of certain types of statistical packages that they're using require them to do that. Most of the more advanced programs now, you can just put the data in like this. So again, just because it's a number doesn't mean automatically it's qualitative. But the idea is the response is what are they saying? When you ask somebody their gender, they don't respond to you, oh, I'm a 1 or I'm a 0. They typically will say, male or female. So that's how we look at this. So qualitative, we have two then different here in this column, two different things. When you collect your qualitative variable, think of something that you'll break down into 2 or 3 different things. And so again, we want to make sure that we get that down first. And then you're going to have an associated quantitative variable. And again, that's typically numeric, so that's pretty much always numbers. And we see systolic pressure. These are like typical systolic pressures. And make sure you put in your unit of measure, right? So we have millimeters of mercury or whatever. And so I want to break this down. The idea of this discussion is you're just going to compare descriptive measures between 2 or 3 groups. We have 2 here, right? So we're comparing the systolic pressure between males and females. And we're going to look at what we call measures of central tendency, measures of variability, the shape of the distribution, and tables. But for in the book, you'll see that they talk about frequency tables and relative frequency and so on. That'll be in with the other the project. Okay, so now also on the discussions where it says by day 3, that is not a due date. That is not an absolute due date. So it's very important that you understand uh, when I look at the discussions, I give you a chance to post, then I will respond, and then everybody gets a redo. So I'll try to tell you what you did wrong, then you go back and now you can't do that every day of the week. You can't like redo it and then post it again and then expect me to keep. I'm just giving you the answers that way. But in this type of discussion, you do need a little bit of guidance. And if you put in the effort, you do the homework, you look at the project, um, you should be able to get it pretty much right the first shot. I'll respond and tell you basically what's going on, and then you'll get a chance to do it again. And so that has worked out well. Okay, so we just need to remember that is that if you don't post by day 3 and you're not ready to post anything, don't just throw something up there. Uh, because you're saying, "Oh, it's due. I'll get an F if I don't. He'll take off points." And no, I won't. You've got to get it done by day 7, but by day 3, you should have something ready day 3, day 4 to put up there for me to look at so I can respond and get that back to you. Okay. Now you're going to have your data table in your discussion. You're also going to have another table that's going to look exactly like this. Okay. And you're going to fill in the numbers. So these are the measures of central tendency, the mean, the median, and the mode. And these are the measures of variability, the range, variance, and standard deviation. And you could think of as the minimum and maximum, but those basically are how you get the range, the maximum minus the minimum. And you're going to do that for each group. So that means you have to separate those. Male, you're going to do that. And then for females, you're going to also have their own. So it's kind of like you're working with 2 separate groups. And then we're going to go ahead and open up StatDisk and look at that. And then you're going to compare the measures of central tendency for each group first. So for the males, I'm going to look at the mean, median, mode and think when you typically talk about a distribution, you pick one measure of central tendency. Okay. Typically, you just do one. We're talking about descriptive statistics, right? So one of these will be more appropriate probably than the other, right? And sometimes it really doesn't matter. Sometimes they'll come out like very, very close, so it wouldn't matter. And again, we'll look at these and we'll see the range is affected by outliers, for example. So if you have outliers in your data set, you're probably not going to want to use the range. The variance is when you square the deviations about the mean and you sum those up. And so those are very much larger than the numbers in your data set up here. So when you square those, they come very big. So most of the time, if not all the time, the variance is not a good descriptive measure, okay? It's not a good measure. It's a great statistic in inferential statistics, not so good in descriptive, okay? But a lot of times you're going to use the standard deviation. That's the most popular measure variability. And we're going to do that for each of the groups, okay? And then you're going to discuss the shape, left skewed, right skewed, symmetrical. Support your response by comparing the mean and median. If the mean is greater than the median, it's right skewed. If the mean is less than the median, typically we say it's left skewed. And then we should also see that within the histogram. Box plot for each. Then we're going to put those on one graph, and then you're going to post and then again, remember in a discussion, you're also posting to your colleagues with something interesting. So just don't say, "Hey, that's a great idea." I mean, we really want you to post some thought. Think about it. We want a thoughtful post in there. Okay. And you can get those in, you know, once you look around. We want you to read and see what everybody else is doing, and make sure that you're not using the same idea as somebody else and have all the same variables as somebody else. That's not going to work. Okay, so let's go ahead and go back to this, and I'm going to pull up stat disk. Okay, let's just let me put this down for a minute so I can get this opened up. Yeah, here we go. All right, so we need to go to stat disk, and remember you type in statdisk.org. Okay, I think one of the videos I said .com, just by habit, but and we're using the online version. You should be using the online version. If you downloaded it and you're comfortable with the other and it's working, and that's why we went to the online version, because especially the Mac users were having issues. But I'm putting in my email address, and I don't know if I have to have the whole email address in there. And let me just double check. Yep, I have to have the email address and the whole thing. Okay. Okay, so I'm going to try to get these both up here. Okay. Now, the stat disk, there we go. Okay, there it is. Just a couple comments on here. We're able to use this because we have, one of the books at Triola, an author, as part of the writing. And over here on the left, you'll see that, these are some data sets that were used, and this, and some of the recent functions that were used. But I wanted you to get on here and notice that there's a stat disk manual that we're going to update, working on that too throughout the course, but it's the StatDisk 13 version, and now they have a StatDisk 14 edition manual that does work with the online version. So if you get stuck on something and you're looking for some maybe quick help, there are instructional videos on how to use it, but there's also this manual that you can go into. Okay, so now I'm going to take the mail data here and put it in there. So my number one, my column one, that's the mails. And again, I'm just copy and pasting those in separately. And, we don't put them all in one column because we're not evaluating them together. We want to compare the males' data and then the females' data separately. And so that's done a lot of, two group comparisons are done a lot. And we want to see, here's what we want. And the data tools, and again, I know this is squeezed in a little bit, but it'll be easier to use. And you can, all right, there it is. So here's the top. We don't have to open up any data sets because we just type the data in. Okay. So when you were doing the project, you would go into data sets and open that up, and then it would say like open elementary 13th edition or something, and then you would have to pick from there, and then the data would appear here. So we don't need to do that. We pretty much typed it in. Okay. Now, if you go into data, you got lots and lots of things you can do, and for now, we just want descriptive statistics, right? That's what this discussion is on. So I'm going to click on descriptive statistics, and then I have to select the column. The males were in column 1. Okay, evaluate. So the program works really neat. I mean, it does all this stuff for you right away. So you just have to transfer the information. So the systolic pressure, the mean for the males is 119.9. So you put that in there. And then, of course, the median is 122. And then the mode may not even be on there because it may not be one. So I'm not seeing one. So none of the data values repeat. Remember that the mode is the data value that occurs most often, and nothing. So if we look at our data set, then we don't have any ones that repeat. So that's okay. You don't need one. So just put no mode, right? None. So that takes it out of the running of being used. All right, the range I saw on here, the range is 50, would go in here. Of course, the variance is given right here, S squared, 339. See how big that number is? That's what I was mentioning about why the variance is not a good measure, a descriptive measure, because, I mean, how does that help us with blood pressure is like 119, 120, and then all of a sudden you have a number that's 339. So right now it doesn't seem to make sense. So we don't typically, like I said, use that as a descriptive measure. Now the standard deviation is more appropriate, 18. So that gives us the idea of the variability within people's, in this case, the male's blood pressure, right? And the minimum and maximum are on there. Okay, good. So we got that. And then we could go to 2 for the data, evaluate that. And now we got the same thing for the females. The mean is given, right? There's your mean, and the median, and the variance standard deviation. So all that stuff's there. All right. And then you're to compare, again, the measures for each group stage, which one would be the best measure. So the mode we don't even have, so that one is out. The difference between the two, which one is better, it all comes down to outliers. And do you have a value? When I say outlier, I mean a value that is way bigger than all the other ones, or way smaller than all the other ones. Like here's one. If we look at the maximum of 165, that's pretty high. That's kind of like an outlier right there. So it pulls the mean to the right of the median if it's a high outlier. So see, our mean is slightly larger than the median, so it's a little bit right skewed. So when that's not really that different, right? 120.81. So really either of these would be okay. If the mean were way bigger than the median, then we would use the median because outliers pull the mean away from the middle of the distribution, okay? And it looks like since we have an outlier, we may want to go with the standard deviation. The range is also influenced by outliers. Okay. Discuss the shape of each distribution. Well, let's look at it. Well, geez, It's pretty uniform right there. If we look at the box plot, now this one, when you have this long line on the box plot, that outlier up there kind of looks like it's right skewed a little bit. And when we compare the mean and the mean's greater than the median, so it is a little bit right skewed. So, and this normal distribution they talk about in a chapter. This is not part of this, so you don't have to worry about that. Create a box plot. Let's go back up here and let's go to data and box plot. Now, if you just want a histogram by itself, let's go to that first. Let's do a histogram. Select males. You can set these in the project so you learn how to do this first, and that's why you do the projects first. It talks to you about these. Or we could use the auto fit, and it's kind of nice and symmetric there. Right? But let's go back up to data and do a box plot. And we want to compare the men, column 1, women, column 2. You can do box plot or modified. Let's just do the box plot. And there, you get your both of them. So you can compare both groups very nicely on the differences in the distribution of those systolic blood pressure. So box plots are really popular. They're a great way to compare groups. You can put as many groups in it, and it still works very well. Histograms, not so great. Box plot's much better. And so that's pretty much it. You have to, explain and get involved in the discussion, though. But you should be able to get off to a good start on that discussion. And then remember that again, first time you post that, I'll take a look at it and let you know what I think, and try to guide you in so you can get it, done completely. And I think everybody's shooting to get it all done completely correct. That's your goal. That's my goal for you. And okay, so we're going to stop this video now.